Alright, so here we're going to learn about the nomenclature of benzene and benzene derivatives. And on page 2 of your notes for chapter 17, it kind of gives some rules that should be kind of memorable from common IUPAC naming. And the first rule is number to give the lowest possible numbers for all substituents. So that's the first rule, and the compound on the page, the first one is this here. So we want to number to give the lowest possible number for the substituents. We want to, number 2, alphabetize the substituent names, and then we're going to skip part 3 right now. And then the other thing that I'm going to say is that molecules that are contain this 6-membered ring with these 3 pi bonds are called benzene. So benzene. So essentially you're going to do the same type of naming that you would do for any type of alkane, but you're just going to end in benzene. So benzene would kind of be the family, so in the idea that we have a prefix, which is our substituents, that's going to be the same as always. Then the parent and suffix is just benzene. So take a minute, pause the video, try and name this one, and then restart it, and then we'll name it together. Now that you've restarted it, we're going to number to get the smallest number for all substituents. So numbering this direction gives us a combination of 1, 2, and 4 substituted. If we numbered the opposite direction, we'd be 1, 3, 4, so a larger combination of numbers. So we have a 1, this is 2 carbons long, this is an ethyl group. In 2, we have a propyl group. And then in position 4, we have a bromine. So we are going to just have those be the prefix. So we're going to alphabetize them. So bromine is the first alphabetically, so this would be 4 bromo, 1 ethyl, 2 propyl, benzene. So pretty straightforward. Should make a lot of sense. Definitely let me know if it's not making sense to you. And the next thing on the page deals with kind of a new nomenclature system that we are going to deal with benzene compounds. And that is the naming of different places on the benzene ring according to a different substituent. So if we have some substituent R, both of these positions are called the ortho position, and O stands for ortho. Both of these positions are the M positions, or meta, and this position down here is called the para position, or P. So we can name compounds with 1, 2, 3, whatever, but in some cases you will also see them named para blank, ortho blank, whatever. So let's give an example of that. So if we had a molecule that had bromines in this pattern, and actually let's do this is the one that's in your notes. The one in your notes would just be called meta bromobenzene. But let's just to make a point, I want to switch it to a chlorobromo benzene. So according to this bromo here, this bromo, if we're talking about that bromine, this is the para position to that bromine. These would be the meta positions to that bromine, and these would be the ortho positions to that bromine. So this nomenclature is with regards to whatever substituent you're talking about. So that's para, meta, ortho with regards to that bromine. If we're talking about the chlorine, the ortho position, the para position for the chlorine would be here. It's the 4th position away from it. The meta positions for the chlorine would be here and here, and the ortho positions for the chlorine would be here and here. So what is para, meta, ortho for one substituent is not the same as for a different substituent. So how would this be named? So we like it when things are alphabetized. That's kind of a standard rule of nomenclature. So this can either be chlorobenzene or bromobenzene. Because the full parent name of it, we want to have the lowest alphabetical order. We're going to call it bromobenzene. So we're going to call this bromobenzene. And this chlorine, with regards to the bromo, is in the meta position. So this is going to be called metachlorobromobenzene. So that tells us the chlorine's in the meta position, the bromo is always in position 1. So that is how we would use this para, meta, ortho naming system. And you will definitely see some of these in your notes. I will tell you though that on the exam, you will need to know what a para position is, what an ortho position is, what a meta position is. But as far as questions about naming, I prefer that you use the 1, 2, 3, 4 nomenclature. That's kind of the more standard IUPAC nomenclature. So that's why I go with that one. So that's kind of naming with benzene. Why is it important to know para, meta, ortho? It turns out that in chapter 18, we are going to do reactions of benzene derivatives. And in those reactions, depending on what the substituent is here, the group that is going to be added to the benzene ring will either be directed to two specific positions. So we might say, oh, if R is a methyl group and we're adding an electrophile to the ring, it's going to add to the para and ortho positions, not the meta position. So we call groups para-ortho directors because they're directing groups to those positions, and other substituents in this R position would direct things to the meta position. So that's the point of this nomenclature. Okay, so on the next page, on page 3, so we'll switch to page 3 now, we are dealing with common benzene derivatives. So common benzene derivatives, and they're called common root names. So common benzene derivatives, just we use a name for a specific type of benzene, and then we say what the other substituents are. So one of the most common, and you'll have to know 4 of them. I try and make you guys know the things that the American Chemical Society wants you to know, and they definitely focus on a few of these common roots. And one of the common roots is a benzene ring with a methyl group off of it. This is called toluene, and I'm sure many of you remember seeing toluene at various times during the laboratory sequence in Chem 236. So this is toluene. So if we had a molecule like this, where we have a CH3 in this position, and then we might have a bromine there, what are we going to call this molecule? Well, toluene, the major substituent of toluene is this methyl group. It's always going to be number 1. So whenever we have a toluene substituent, it's just assumed, or whenever we have a toluene derivative, it's assumed that the methyl group of the toluene is position 1. So then we would just number around the ring like that. So for a molecule like this, if that's position 1, then we're going to make the bromine the lowest possible number, which would be position 2. So this molecule could be called 2-bromo-toluene. So pretty straightforward. We would do kind of naming as we would expect from there forward. What about this molecule here? So this is toluene. This is called phenol. Why do these have kind of weird names? They have weird names, and I don't know, maybe weird's a weird word for them. Why do these have unique names? Well, people used them before they knew what the chemical structure is. So one unique thing about phenol is it was used so that the first doctor that kind of pioneered surgical techniques that were aseptic, so not allowing a bunch of infection following surgeries. He would spray down his patients and all of his materials with phenol. It's somewhat acidic, so it has antimicrobial properties, and that allowed his patients to have better outcomes. So why is phenol called phenol? Somehow it was just named that way back when, and we're using that same name now. So this is phenol. So what would we name something like this? Okay, so it's going to be named phenol, and phenol has the alcohol in position 1. So numbering this way would give us the lowest combination of substituents. Then we need to alphabetize those substituents. So I would be an iodo. This is an isopropyl. So IO is earlier in the alphabet than IS. So this one would be 4 iodo, 3 isopropyl, phenol. So that's phenol, another common root. What else do we have? We also have anilines, which have the amine group. So this is an aniline. And another one we have is styrene. I mentioned styrene in chapter 15 because polystyrene is a polymer of styrene. So lots of our plastic materials are made from styrene. So aniline, let's do a quick example of that. And actually I'll write up 2 different things. And then you can pause the video and try and name them. Oh, actually, we'll just, yeah, we might as well. There we go. So pause the video, try and name them, and then come back. So now you're back. We have to name this aniline. We're going to name to give the lowest number to all substituents, which means we could go clockwise or counterclockwise until we get to the secondary rule, which is we want the lowest numbers to have the lowest, the earliest letters in the alphabet if it's a tie. So essentially, if we numbered this direction versus this direction, it's a tie. We'd have a 1, 2, 6 substituted benzene ring. But by numbering clockwise, we get 2 bromo, 3, 6 chloro. So the earlier thing in the alphabet gets the lower number. So this would be 2 bromo, 6 chloro, aniline. Nice thing about benzene rings, there's no stereocenters, so you don't have to do any RRS with this stuff. What about styrene here? You just have a propyl group in that third position, so this would be 3 propyl styrene. So pretty straightforward. So the last thing about nomenclature is just sometimes you'll see benzene as a substituent group, and if that exists, sometimes it's shorthanded. So for instance, this is an amino acid. Amino acids are what make up our proteins. This amino acid has a big benzene ring in this spot right there. If someone was drawing a protein, they'd have to draw a lot of these benzene rings. It would take a lot of time. So instead of drawing that benzene ring every time, it's often abbreviated pH. So pH is a benzene ring, and it's often called a phenyl group. That's what the pH stands for, a phenyl group. What is this amino acid? This amino acid is called phenylalanine. All one word. I kind of put a space there, but it should have been all one word. So that's kind of the final part of the naming. So hopefully that will allow you to understand how we name compounds that have benzene in them. Please let me know if you have any questions. What do I do with my hands?